me get my head together here before I do it. Okay. We have the sum as k goes from 1 to infinity. 3 ln squared k over 7 over k squared.
You did 7 over 2.
Yeah.
Oh, okay. Yeah, I thought, you know what, that's not making sense. 7 over, sorry about that, that's not wrong. I mean, that's not right. K to the 7 halves, there we go, is that correct? Okay, there we go. This is one of those, I don't know, the integral test might be a nightmare if we try to do the integral of that, okay? I'm not sure how that would work out. And it's not a pure p-series because of that natural log on top. All we got is a comparison or limit comparison. That's all we have. And my suspicion, do you have a suspicion? Do you suspect what this will do, converge or not converge? Do you suspect that? It will converge. And the reason I suspect that, do you have a reason?
Yes, because if you were to do just 1 divided by k, 7 divided by 2, if you were to look into the p-series, the part is greater than 1, so
Okay. Well, let me say this. Anytime k is raised to a positive power, it will eventually grow faster than ln k. Okay? And since the denominator will eventually grow faster than this numerator, it's likely to converge. Not guaranteed, but likely. Because there are examples where that doesn't happen. Okay, you might be tempted to compare it with, this is going to be wrong. Don't write this in your notes. Compare with 1 over k to the 7 halves and do the limit comparison test. So this might be your temptation, and that would be a logical thing to do because 7 over 2 is greater than 1, so we know that converges by the p-series, right? So let's do limit comparison with this and that over that. They either both converge or they both diverge. Real simple, right? Well, watch what happens. Limit as k goes to infinity of this over k to the 7 halves over that. Well, what's going to happen to those k to the 7 halves? They're going to cancel out, and we have 3 ln squared k, and that's going to equal infinity. What does that limit comparison test say?
1 and
It doesn't say it here in the book, but do you see it has to be less than infinity? It has to be finite, right? It has to be finite. And I'm surprised they didn't say it in the note, but if it goes to infinity, then the test is inconclusive. That make sense? And that went to infinity, so the test is inconclusive. So we have to do something else. We have to choose something different to compare it with. And I'm going to choose 1 over k to the 13/4. And this is going to be right. And it makes no sense why I would choose that just looking at it. Let's go through it and see what happens, and maybe it'll make sense. Okay? Here we go. So we're going to do the limit. This is going to be correct, so you can write this in your notes. I think it is. Let me double check. 13/4, yeah. This will be right. So we're going to do 3 ln squared k over k to the 7/2 over 1 over k to the 13/4. So multiply by the reciprocal. What do we need to do? What can we do with those exponents? One's on top, one's on bottom. So with the exponents, we subtract. I'll do some scratch paper work over here. So 13/4 minus 7/2. That's 13/4 minus 14/4. Get a common denominator, and that's -1/4. So this equals the limit. K goes to infinity of, so we're going to have k to the -1/4, which is 1 over k to the 4th, right? So I'm going to write this as, let's go ahead and take the 3 out here. ln squared k over k to the 1/4. Now, as k goes to infinity, what's the numerator going to? Natural log of infinity is infinity. And the denominator is also going to infinity, isn't it? We have infinity over infinity. What do we do? L'Hopital's rule. All right. I'm going to do it with the k. I'm not going to rewrite it in terms of x because we're going to run out of time. So to do the derivative, the scratch paper work of ln squared k, that's like ln k squared. We bring the 2 down. And then times the derivative of the inside is 1 over k. So we get 2 ln k over k. So we get there. And now the derivative of the denominator will be 1, scratch paper work, dx of k to the x to the 1/4. Bring the 1/4 down and subtract 1. Same thing as 1 over 4x to the 3/4. Okay, so multiply by the reciprocal. times 4k to the 3/4 over 1. Now we do this 3/4 minus this 1, 3/4 minus 4/4 is negative 1/4, so that, well, let's take this 2 out. 2 out here times 3 is 6. Actually, let's take the 4 out too, 24, sorry about that. And now 3/4 minus 1 is negative 1/4, so we have ln k over k to the 1/4. We have, I'm going to start speeding up here, we have infinity over infinity again, L'Hopital rule again. So now we have 24, limit, k goes to infinity, 1 over k over, bring down the fourth, 1/4, k to the negative 3/4. So let's do some scratch paper work with this. That's 1 over k times 4 over 1. This is k to the negative 3/4, that'd be positive on the bottom, but when you flip it, it goes up to the top. 3/4 minus 1 there is negative 1/4. So that all equals 4 over k. So now we have 24 times the limit as k goes to infinity of 4 over k, which is 0. All that work for nothing. 0. And we don't have time to really dig into why we chose that 13/4. But here E, they give it to you down here in the answer. It's 1 over k to the 13/4. They give it to you here. 0. And it converges. So when you get to that problem, think about why it is what they give you here, okay? View an example if you need to, but think about why. You saw that it didn't work when we used 1 over k to the 7/2. Came out to infinity. We needed something so that when we subtracted the 7/2, this ends up on top. When we subtracted those, we needed to get something down here so we could use L'Hopital's rule. We didn't want that to end up there. Does that make sense? You'll see when you work through it.
Yeah. So 15 over 4 would have worked. 15 over 4 would have worked.
15 over 4 would have worked as well. I believe so, because 15 over 4 minus 14 over 4 would have been 2 over 4, which would be 1/2. So you'd have 1/2 here instead. I believe it would still work. Yeah. All right, those people I mentioned, would you come talk to me real quick? Oh, wait. Let's fix the attendance.